TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Carat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Carat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Carat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called superjupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time, they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us, in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called eROSITA, to look for X-rays coming from Ansky. At first, they didn't see any. Then, in February 2024, another group of scientists noticed something new: bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name, quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a superhot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed a star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see. They're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space, because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large.
Imagine leaving your house one morning and seeing not one, but two stars shining in the sky. The first one is our good old Sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperatures suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth. And this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. And we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness. Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas, so let's hear them out. Picture this. In the vastness of space, there's a supermassive star shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it, the accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into the celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, the interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon, the birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world. Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant, and elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there will be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen or methane and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires two other cutting-edge technologies: the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns. with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our Sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big swirling conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens, but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, the signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss, because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles and light waves start bouncing off this gas, which disturbs the signal a little bit. So, when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So, even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our Sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom, we've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the Moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the Moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they included that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.